basically we're going to be looking at the properties of the sides of the three sides of the triangle, and from that we're going to be able to have a few different buckets, categories of triangles that we can classify. So the first one, again, it's pretty simple. The first one is going to be, here's a triangle. Okay, I'm going to do my best to draw it. I'm trying to draw 3 equal sides to this triangle, right? Now in geometry, if you're drawing something by hand, and you're not a textbook printer or something, if you're drawing something by hand, you need to, and you're trying to show that 3 sides are equal or 2 sides are equal or something like that, you need to have some symbol to tell the student, tell the reader that they're equal. So what you do, what you'll see all over the place in geometry, is that if you put a little bar through it, and I'm doing this in red, a little bar through that and a little bar through that, the red little bar just means that this side's congruent to this side's congruent to this side. Again, congruent is just a fancy word that means equal. So that's all it really means. But I'm trying to use the terms so that you will not be lost whenever you see them in the textbook. So this triangle with 3 equal sides is called an equilateral triangle. Okay, an equilateral triangle. It's an equilateral triangle. Okay, and all this means is sort of what we already shown here, that all 3 sides are congruent. Which, don't forget, congruent just means they're equal. So anytime you see a line with a little bar through it, and a line with another bar, and a line with another bar, then you'll know everything with that bar through it is congruent. It's really a similar thing. You know, before we had 2 parallel lines, and we said, well, if these are parallel, then you'll put one little triangle here and one little triangle here, and that little symbol means that those 2 things are parallel. Well, you know, it's one symbol that you invent for lines to show that these are parallel. This is another little symbol that you see here in triangles, or it could be in any figure. It doesn't have to be a triangle. These little bars mean that these lengths are equal. Congruent is really the proper term, but equal is really what the point is. So that is one type of triangle, the equilateral triangle, okay? So anytime you see a triangle that has 3 sides that are exactly equal, you just put it in that bucket called equilateral triangle bucket. Okay, another type of triangle is the slender triangle like this, okay? And in this triangle, I'm going to say that this side here is congruent to this side there, which means, again, it's just equal, but it's obviously not equal to this shorter side here. So in this triangle, 2 of the 3 sides are equal, so you get this long, slender triangle that's on a short, stubby base like this, okay? And this type of triangle has another name. It's called isosceles. So it's isosceles, okay? Isosceles triangle. And what is isosceles triangle? It just means only 2 sides are congruent, which just means that only 2 sides are equal. So again, if you're given a problem, and we're going to do some problems in a minute, and you see that 2 sides are equal or congruent with these little marks, but the third side is not, it's obviously not an equilateral triangle because all 3 sides have to be equal for equilateral triangle. It's an isosceles triangle, which just means that 2 of the 3 sides are congruent. Okay, and again, this is classification by side. That's what this means. We're looking at the sides of the triangles, and we have these properties, 3 sides equal, 2 sides equal, and we're putting them into buckets. We'll do different kinds of classifications here in a little bit. Okay, now let's say you have a triangle that doesn't seem to have any of its sides congruent to each other. So let's say you had something that looked kind of weird like this. You know, you had a little side here and a longer side here, and yet an even longer side. Let's see, well, that's not the best example here. Trying to draw it a little bit clearer for you. Let's say you had a side like this, and a side like this, and then a side that goes down like this. That's what I'm trying to draw. So you've got one side clearly this long, another side that's a different length, and then another side still completely different from the other 2. So in this type of triangle, right here, none of the sides are congruent. None of the sides are equal. So it's different completely from the other 2. And so this one has a special name. It's a classification of a triangle. And this triangle is called a scalene triangle. Okay, it's just another word. Scalene triangle just means none of the sides are equal. So the definition of that is no sides are congruent. And I'm just going to abbreviate congruent with CONG. So here you have the three kinds of triangles classified by their sides, and we will do different kinds of classifications in a minute. Again, it's just an exercise in learning some terms. You've got three sides of the triangle that are congruent, you call that an equilateral triangle. Two sides that are congruent, you call it isosceles. And if you have a triangle that's just weird, random, odd shape with really no symmetry to it, different sides, different lengths all over the place, then that one's called scalene. No sides are congruent at all. So let's go ahead and practice this. We're going to identify the triangles over here, and we're going to get some practice. So if you have on your test or your homework, you have a triangle that looks something like this. Okay. A lot of times in the book, what you'll see is you'll see a triangle and you'll see a number along each side. Okay. Now notice that there are no congruent marks here. Okay. They're not going to, they're not going to always give you the answer just outright. Like here's the answer. I mean, you have to do a little bit of thinking. This number represents the length of this side. Okay. And this number, the length of this side, and this number, the length of this side. So when you see a triangle with a number along a side here, that is the length of that side. Now, is this length in inches, or is it in feet, or is it in meters, or is it in miles? Who knows? It really doesn't matter. What matters is that all three sides are equal. It doesn't matter how big this triangle is. It doesn't matter if it's huge. This could be 3 million miles, okay? It doesn't matter. But as long as this side is equal to this side is equal to this side, no matter what length it is, we show that those things are equal. And so I think by now you can probably figure out that this is an equilateral triangle. Okay. So all you really need to do is go and look at the sides of the triangle and figure out if they're equal. Okay, let's say you're given a triangle that looks like this. Okay. The length of this side is shown to be 3. This is given in the problem. The length of this side is shown to be 4, and the length of this side is shown to be 5. What triangle would that be? Well, the first thing you need to do is go and ask yourself, is it equilateral? Well, it's obviously not equilateral because all three of the sides are different. Then you would look at your next classification, isosceles, and see, are any two of these sides equal? The answer is no. So in this case, all three are completely different. No sides are congruent at all. So this one is a scalene triangle. Scalene triangle, okay? And we'll do one more quick example. Shake it up a little bit. If I had a triangle that looks something like this, and let's say in your problem, it actually put a mark here and a mark here. So in this problem, you don't know the length of the sides like you do here, but the problem is telling you what? Well, this mark and this mark means, by definition, from what I've told you here, that these two sides are congruent, which just means they're equal to one another, okay? So two sides are equal matches up with this definition here. Two sides being equal, or congruent is really the proper term. So that's an isosceles triangle. Okay, isosceles triangle. So again, I'm not going to do any more problems of this type because I think you get the hang of it. Equal sides, equilateral, all different sides, scalene, two sides the same, isosceles triangle. Okay, now one thing that I want to show you before we really move on is I want to define a few more terms associated with isosceles triangles. So here's some more info on isosceles triangles. Okay, so I'm going to draw an isosceles triangle here, just a big one, okay? And obviously, this side's congruent to that side, which is different from the third side below. That's the definition there, okay? And I just want to show just a few different terms because sometimes you'll get asked this on your test, okay? This angle up here at the top, where the two pointy ends come together, okay? Let me draw that in a different color so you can see it. This angle right here is called, it has a name, and it's called the vertex angle. Okay, the reason they call it the vertex angle is just because every isosceles triangle is going to look long and skinny, and it's going to have a point to it because two of the sides are equivalent and the third one is not. So, in fact, I just said something not quite true. Every isosceles triangle is not going to be long and skinny. I mean, you could have one actually with a super long base, you know, and something like this. This is also isosceles. These two sides are the same, like this, but this one is different. So it's not actually true that every isosceles is going to look tall and skinny. But the vertex angle is the angle that is between the two congruent sides. Okay, so the angle up here at the top, so to speak, if you draw it like this, where the congruent sides are coming up and meeting at a point, the angle in the middle there is called the vertex angle. So sometimes on a test you might be asked, what's the vertex angle there, and you'll know how to do that. Okay, a couple of other things. One of these congruent sides, there's two of them. This is called a leg of the triangle, and the other congruent side is also called a leg. I think the reason they call it legs is because, you know, we are humans, we have two legs, right? Two things to stand on. And so the triangle, if you kind of look at it, it's sort of standing on these two legs that are congruent, that are equal to one another. So we have two legs. This odd man here, it's not a leg. It's called something else, and that's called the base. And I think you could probably see why. I mean, it's the base because it's the bottom. It's the bottom underneath the two legs that are holding it up, which has a vertex angle here between the two legs. Okay? So that's all I really wanted to show you here, just some terms, because sometimes on the test you'll be asked to classify those things. You know, and again, it's just like anything else. You have some terms, you have some definitions. Once you get those down, then the rest of it really just kind of falls into place. Okay, so the next thing we want to do, we've already talked about classifying triangles by their side, how many sides are equal. Okay, now we're going to classify triangles by the angles in the triangle, the angles inside of the triangle, and I think that'll become clear here. So here we're going to classify triangles by angle, and you see I'm using my little notation, my little abbreviation, my little symbols here to get you used to it. Classifying triangles by angle. That's how you read that. Okay. So let's do that. Let's draw an equilateral triangle, just because it's something we're familiar with. I think everybody can visualize. Here's an equilateral triangle, okay? Which by definition means all three sides are equal. All three sides are equal, okay? Now it turns out, I'm going to show you why here in a second, but it turns out that every equilateral triangle, you know, obviously you have an angle here between this side, and an angle down here between this side and this side, and an angle here between this side and this side. That's what these three angle symbols mean, okay? When you put in a triangle a symbol like this in the corner, it's kind of like the mark we made here, to show congruency here. When you put an angle symbol here and an angle symbol here and an angle symbol here, it implies that these three angles are congruent, okay? So, indicates that the angles are congruent. Okay, these three angles are congruent, which just means those three angles are equal, and so this is what we're going to call an equilateral triangle. Equilateral triangle, okay? So really, all I'm saying to you is, when you think back to what we just learned, all three sides are equal, okay? Are congruent, okay? And we know that that's called an equilateral triangle because we just learned about that a few minutes ago, okay? What I'm also telling you is that for every equilateral triangle that you could possibly draw on your paper, all three angles are equal. Congruent is the proper term. So use the symbol here to indicate congruency. This means this is congruent to this is congruent to this. I haven't even mentioned what the angle is. I'm just saying that they're congruent with one another, okay? And you should probably get a pencil out and try to figure that out for yourself. Any triangle that you draw that has three exactly equal sides, just get a ruler out. This side, and this side. If they're all equal, by definition, the angles in here are going to be congruent or equal to one another. You can't draw a triangle any other way. Get your ruler out and figure that out for yourself. It's always going to be the case. So, just like we could draw triangles and classify them by side, let's say you didn't know that these sides were equal. Let's say you didn't have a ruler. You couldn't figure that out. Let's say the problem didn't tell you that. The problem didn't tell you that these sides were equal. The only thing the problem told you was that these three angles are equal. That is enough information by itself to show that it's an equilateral triangle. So remember that. Equilateral triangles have equal sides and congruent angles. Everything is equal in an equilateral triangle. Kind of makes sense, right? So all you need to know is that the angles are the same, and then you know that it's an equilateral triangle. Okay, let's draw a different kind of triangle here. Let's draw a triangle like this. Okay, I'm going to write something over here and we'll talk about it. This type of triangle is called an acute triangle. And remember, we're classifying by the angles. And it's acute because the three angles inside are acute. That's all you have to know right there. If you have a triangle and you're trying to classify by the angles inside, if this triangle has three acute angles, then it's called an acute triangle. What's an acute angle? Just for a refresher, 90 degrees is like this, okay? Exactly perpendicular, 90 degrees. Anything less than that, anything like this, is an acute angle. Anything greater is an obtuse angle, okay? But right now we're talking about acute angles. So anything down here is an acute angle. So you can see right here that this angle is less than 90 degrees, so it's acute. This angle is less than 90 degrees, so it's acute. And this angle is less than 90 degrees, so it's acute. All three of them have to be acute. Then you call the triangle an acute triangle. So on your test, it may give you an angle here, and an angle here, and an angle here, and you have to figure out what kind of triangle it is. Well, it's not an equilateral triangle because they're not equal, but this one is an acute triangle, okay? And we'll do some problems to solidify this. Now, what if you had a triangle that looks something like this? Something like this. Okay, this type of triangle, now I'm just going to go ahead and write it down here and we'll talk about why it's the case. It's called an obtuse triangle. Okay, and the reason is because it has one obtuse angle. One obtuse angle. Okay? So the best way I can describe this is anytime you see a triangle that just looks kind of flattened like that, there's really no symmetry to it, but it's just kind of broad and it's kind of opened up. You see how it's got this really big angle here? This is an acute angle, very narrow angle, less than 90 degrees. This is an acute angle, very, very small angle, less than 90 degrees. But this one here is opened way up. Remember, this is 90. This is anything up here is an obtuse angle. And so this, you can see it's greater than 90 degrees. It's opened up. This has one obtuse angle, so it's an obtuse triangle. Okay? And the final one that I want to show you is actually very, very important. This is actually the one you see almost all the time. Here's a triangle, and you've got a right angle here, which means this angle right here is 90 degrees, and this means you have a right triangle. Okay? And the way you figure that out is you have one angle that's 90 degrees. Okay, that's exactly what that means. And this little square here, down here to show at this angle symbol right here, this means by definition that this angle is 90 degrees. So right triangles are actually very, 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 very important. I can't overstress it enough. Right triangles are used beyond geometry into trigonometry and calculus, and they're very important. All of these are, important to understand, but the right triangle comes up over and over again in advanced math as you go on. So pay some attention to it. It's a special triangle that has two legs here that meet at exactly 90 degrees. It doesn't matter what the rest of the triangle is. If it has one 90-degree angle, it's a right triangle. So really quickly, and we'll do some examples here, if you have a triangle with three equal angles, it's equilateral. And that's going to imply the three sides are equal as well, which is what we talked about before. If you have a triangle with all three angles that are acute, which is less than 90 degrees, you call it an acute triangle. If you have a triangle with one big angle, greater than 90 degrees, one obtuse angle, you call it an obtuse triangle. And if you have a triangle with one 90-degree perfect right angle, you call it a right triangle. Okay? So I think the best way to proceed is just go ahead and draw some more triangles on the board here. And we will get some practice. and applying exactly what was just learned here. So let's say the first triangle that I have is a triangle that looks something like this. Okay? And the only thing that you're given in your problem is that this is 55 degrees. Actually, let me make sure it's clear. Okay? This angle is 55 degrees. This angle is 55 degrees, and this angle is 70 degrees. They can use an arrow to show you this, or they can write the number right here in the corner telling you that. Okay, so what kind of triangle is this? It's not an equilateral triangle because these angles are not the same, okay? But I do have 3 angles that are acute because all 3 of those angles are less than 90 degrees. So this is an acute triangle. Okay, first problem complete. Second problem, let's say I have something like this, okay? And let's say I have, it tells me this is 60 degrees here, 60 degrees here, and 60 degrees there, okay? 60, 60, 60. 3 angles exactly the same, which means I have an equilateral triangle because all angles are the same. So this is equilateral. Okay, third problem. Let's say I have a triangle that goes like this, and the only thing I know is it has a symbol there that looks like this, and I have a little arrow that tells me this is 30 degrees, and I have a little arrow that tells me this is 60 degrees. What kind of triangle is that? Well, you really don't have to do much thinking at all. If you have one right angle, which is a 90-degree angle, all you need to have is one of them, and it's automatically called a right triangle. Right triangle, because it has a right angle, okay? And then the final one here, I'm going to have a triangle that goes like this, way out here like this, way out here like this, and I'm going to draw them out because I don't really have much room. This is 20 degrees over here, okay? This one I can write here, 135 degrees, and that angle right there. And I don't really have much room over here, so I'm going to put right here 25 degrees. What kind of triangle is this? Okay, well, it's not an equilateral triangle because all the angles are not equal. It's not an acute triangle because this is an acute angle and this is an acute angle, but this one is not because that's greater than 90 degrees. That's an obtuse angle. And if you look at this, all you need is one obtuse angle, which means greater than 90 degrees. One angle makes an obtuse triangle. So this is obtuse. Okay, now we've done a good introduction of triangles at this point, okay? We've introduced the concept of the triangle. We've talked about the angles inside. We've talked about the equilateral, the scaling, the isosceles, classifying by sides, okay? We've talked about the angles in a triangle, classifying them by angle, equilateral, acute, obtuse, and right. And we've done a few problems. So we've got a good foundation to move forward. And with anything else, it's a matter of learning the terms. You can't learn a foreign language without understanding some vocabulary. You can't do well in geometry without understanding some vocabulary. You get past that hump, watch this part of the video a few times so that you get it up here and where you can recall it quickly, and you'll do perfectly well as you progress on in geometry.
Learn anything at mathandscience.com.